Okay, so if you look at the warm-up, it says solve each by the method indicated. But the first thing we're going to talk about how you can solve a quadratic equation. So we have now talked about a couple different ways. Um, Obviously, we can factor it. Okay, I always usually try and factor first. And on Monday, we're going to talk more about like when to use what. But I always try and factor first. And then you could complete the square, or you can solve by taking square roots. Okay, so this couple things about this. You can always complete the square for the most part. No, you can, but just we're going to talk about today when you wouldn't want to. You can't always factor, but I always check it. This is the one here, the taking square roots. You can only do that if you have a squared term and nothing else with a variable. Okay, so if you look at the first one, it says solve by factoring. So my a value is 1. I can go right into my two sets of parentheses. I have x and x. Two numbers that multiply to be 12 and add to be -8 are -6 and -2. Check your work no matter what your confidence level. X times x is x squared. -2 minus 6 is -x. -6 times -2 is a positive 12. So that means x is 6 and x is 2. Okay. Now for the second one, solve by completing the square. We're going to bring the 12 over. So you have x squared minus 10x, and you know you're going to add in that blank. Then you have -12 plus a blank. Okay, so take your b term, which is -10, divide it by 2, which is -5. -5 squared is 25. Whatever you do to one side, you have to do to the other. Remember, this factors out and condenses down to x minus 5 squared. -12 plus 25 is 13. We square root both sides of the equation, so we get x minus 5 equals plus or minus the square root of 13. The square root of 13 does not have any perfect squares in it, so you cannot simplify it. Bring your 5 over, you get 5 plus or minus the square root of 13 as your final answer. Okay. Now, taking that logic, if you look, it says which method would be easiest to solve for x squared minus 9x plus 13. Okay, so I always try and factor it first. Well, if I try and factor that, I would have x and x, and then two numbers that multiply to be 13. Your only options are 13 and 1. You guys, you're trying to get to a -9 with two of the same signs, so either negative, which is going to get you a -14x in the middle, or a positive, which will get you a positive 14 in the x in the middle. Either way, factoring doesn't work. Okay, so when factoring doesn't work, our next option, we have completing square and taking square roots up here. Well, taking square roots is not an option because I have a squared term, but I also have an x term. So you can only take square roots when you have a squared term only. So I have to complete the square. So if I'm going to do that, I have x squared. Sorry, that's messy. Let's try that again. Okay. So we have x squared minus 9x plus a blank equals -13 plus a blank. So here you would take your middle term, which is -9. -9 divided by 2 is -9 halves, and then you square it. So you are looking at 81 over 4, and whatever you do to one side, you do to the other. So when you get to this, is it possible? Completely. Is it messy? Yes. So that's when we bring in what we're going to talk about today. So quadratic equations can be solved by factoring sometimes, right? We always check it, but it doesn't always work. And completing the square. You can always use completing the square, but completing the square might get messy like it just did, and we're dealing with fractions. So if you have a messy completing the square, then what's your option? The fourth and final option we have is what's called the quadratic formula. Okay. To solve a quadratic equation using the quadratic formula, you have to have the equation in standard form. So you have to be looking at ax squared plus bx plus c equals 0. So remember, same thing with factoring. In order to factor, you have to have one side equal to 0. Same thing with quadratic formula. Okay? So then the same thing, as soon as you solve the quadratic formula, which I'll tell you what it is in a minute, then you're finding your x-intercepts, which are your roots, right? Your solutions algebraically are your x-intercepts graphically. Okay? So what is the quadratic formula? Your quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So it is a big formula, okay? However, if you do it and do it and do it, you're going to have it memorized. No, you won't be given the formula. Honestly, you guys, like we talked about a lot, as long as you do your homework and practice it, you're going to have it memorized, okay? So a couple things before we do the formula as a whole. The expression underneath the radical, which is just the b squared minus 4ac part, okay? We call that the discriminant, okay? Why do we care about that? Well, the discriminant tells us a couple things. If the discriminant is positive, so any positive answer, okay, that tells us that we are going to have two real solutions, okay? Remember from last unit and the unit before, two real solutions means that on your graph, no matter which way you're opening, you are intersecting the x-axis twice, okay? Now, you also could have a discriminant that is equal to 0. If your discriminant is equal to 0, that means you have one real solution, because that means when you graph it, no matter which way it opens, you hit the x-axis one time. Okay. Your last option, hopefully you're kind of expecting what's coming next. We have positive, we have 0. So it could also be negative. Okay. If you get a negative discriminant, that means you have two imaginary solutions, which graphically means your graph, no matter which way it opens, let's say we do down now, will never touch the x-axis at all. Okay, so the first thing we're going to talk about is just the type of solutions you should get. Then we're going to do the quadratic formula as a whole. So this says determine the number and type of solutions for each equation. So we're going to use the b squared minus 4ac part from the front. Okay, here we're already in standard form. So I know that a is 3, b is negative 5, and c is 1. Okay, so b squared minus 4ac is negative 5 squared minus 4 times 3 times 1. So you end up with 25 minus 12, which is 13. Now, because my discriminant is positive, that means I have, notice it says number and type. I have 2. That's the number. The type is real solutions. So if you were to graph that quadratic, it would cross the x-axis twice. Okay. Now, over here, same thing, except it's not in standard form yet. So you need to bring the 72 over. So you have negative 2x squared minus 24x minus 72 equals 0. Okay. So A is negative 2. B is negative 24, and C is negative 72. So my discriminant will be b squared, so negative 24 squared, minus 4 times negative 2 for your A, times negative 72 for your C. Okay, obviously at this point we're going to be picking up our calculator. You guys, I know we haven't picked up the calculator yet, but quadratic formula, we're definitely going to be using the calculator. Okay. So we have negative 24 squared minus 4 times negative 2 times negative 72 And we get an answer of 0. So that means our number and type of solutions, we have one solution, and it is a real solution. That means the x-axis touches the, the graph touches the x-axis twice. So 2 real solutions for the first one real solution for the second one. If we had gotten a negative discriminant, then we would have gotten 2 imaginary solutions. You guys, please, please, please be cognizant of how you're putting this into your calculator, because remember, if you're not using parentheses here, like notice I use parentheses around my negative 24. If you're not doing this, the calculator is not going to give you the right answer, okay? All right, so that's part of what the quadratic formula does. It tells us what kind of solutions we have. Now, we're going to actually solve these using the quadratic formula, okay? Now, here's the deal. Factoring works sometimes. Completing the square works all the time, but sometimes can get messy. Quadratic formula works all the time, but it is time consuming, which you'll see in a minute, okay? So, I am going to use the fact that I know the quadratic formula is this, opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, okay? So, same thing, we need everything to one side. So, we have 2x squared minus 5x minus 12 equals 0. Okay, so my a is 2, my b is negative 5, and my c is negative 12. So, quadratic formula is x equals the opposite of b, so in this case 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times a times c, all over 2a. So right now, you guys, it's just plug and chug, okay? Know that formula. It's on the front of your notes. And write it down however many times you need to do it, but I'm just substituting in a, b, and c wherever they need to go. Now, the next thing I do is I calculate the discriminant. So I pick up my calculator. My discriminant's whatever's under the radical. So negative 5 squared minus 4 times 2 times negative 12. Notice I use the same parentheses as I did the last time. Okay, so I have parentheses obviously around my b value for the b squared, and I have parentheses around the 4 times 2 times negative 12. I end up with 121. So I have x equals 5 plus or minus the square root of 121 all over 2 times 2, which is 4. Well, in this case, the square root of 121 is 11. So you have 5 plus or minus 11 over 4. Remember, you guys, that plus or minus means you have 2 answers. You have 5 plus 11 over 4 and 5 minus 11 over 4. So 5 plus 11 is 16. 16 divided by 4 is 4. That's one of your answers. 5 minus 11 is negative 6. Negative 6 over 4 reduces to negative 3/2 or negative 1.5. So those are your 2 answers. What does that tell you? Remember, just like completing the square, pretty answers, could have factored it from the get-go. But quadratic formula will always work. It's just a little bit lengthy, and there's a lot of places to make mistakes. So if you don't have to use it, I tend to shy away from it. Okay? All right, for the next one, let's try and block that off a little bit. Okay, got to get it in standard form. So x squared, I'm going to bring the 2x over and the 1 over. Okay? So my a value is 1, my b value is negative 2, my c value is 1. I have x equals the opposite of b, so positive b in this case, positive 2, excuse me, plus or minus the square root of b squared minus 4 times a times c, all over 2 times 1. So we have x equals 2 plus or minus. Okay, let's compute that discriminant, which you could probably do this one in your head. But we have negative 2 squared minus 4 times 1 times 1, so 4. You get 0. So the square root of 0 over 2 times 1, which is 2. Well, we know the square root of 0 is 0. So this is 2 plus or minus 0. Well, that's nothing, right? So essentially, you're ending up with x equals 2 over 2. So x is 1. Okay? Now let's think about this. The discriminant tells you the type of number solutions that you have. This right here, my discriminant was 0. Okay, this is your discriminant. If your discriminant is 0, that means you have one real solution. So it makes sense that you came up with one real answer. Here, my discriminant was a positive number. So I should have come up with 2 real solutions, which I did. Okay. Last but not least, we have this one. Okay. So it's already in standard form. A is 5, B is 2, and C is 3. So x equals the opposite of b, so negative 2, plus or minus the square root of b squared minus 4 times a times c, all over 2a. So I'm going to go calculate just the discriminant, which is 2 squared minus 4 times 5 times 3. We get negative 56. So we have x equals negative 2 plus or minus the square root of negative 56 all over 10. So, you guys, your discriminant here is negative 56. So because it's negative, you should be thinking, okay, when I actually work this out, I should end up getting 2 imaginary solutions because that's what the chart on the front of the discriminant told us. Okay, so if you don't, obviously you got to go back and check your math. So let's think about this. We know we want to break down this like we did the past couple days in class. My factors of 56 are 1 and 56. 2 goes into 56 23 times. 3 doesn't work. 4 goes into 56. Let's see, 4 goes into 5, so 4 times 14. 5 doesn't work. 6 doesn't work. 7 doesn't. No, just kidding. I'm lying. 7 does work. It's my favorite one. 7 times 8. And then you're done. Okay, so those are your 4 options. So 1 and 56 isn't going to get us anywhere. 2 and 23, neither are perfect squares. 7 and 8 aren't perfect squares, but this is. Okay, so we really have x equals negative 2 plus or minus the 4, because remember this is really 4 times 14. The 4 comes out as a 2, and then the negative comes out as an I. The 14 stays underneath the radical, and you have it over 10. You can simplify this one more time. You guys, the only times that you can simplify in quadratic formula is if you can simplify in all 3 places, meaning you can simplify here, you can simplify here, and you can simplify here. All of those numbers are divisible by 2. So negative 2 divided by 2 is negative 1. 2 divided by 2 is 1. 10 divided by 2 is 5. So that means your final answer is x equals negative 1 plus or minus 1i, which is just I, radical 14, all over 5. That is your answer. You got 2 imaginary solutions, which we talked about with the discriminant, so you're good. Okay? All right, now, obviously word problems, you guys, they're not that bad. Just make sure that you're reading them and paying attention to what the question is asking for. This says the height of a softball in meters, x seconds after it's been thrown, is given by this equation. When will the ball hit the ground? Okay, well, the height in meters is given it by that, so that means I want the height to be on the ground, so I want my height to be 0. So I'm going to look at this and say, okay, I have negative 4.9x squared plus 9x plus 1.2 equals 0 because I want it to be on the ground. And I am looking for when, so the seconds, I need to solve for x, how long it's been thrown. Okay, now take a look at your quadratic. There's a lot of decimals here. Okay, we all know how we feel about factoring with decimals. Not very good. Okay, so if I'm not going to factor with decimals, I'm definitely not going to complete the square. Because if I complete the square, I'm going to need to bring that negative 4.9 out. I don't want to take out the GCF of negative 4.9. Solve by square roots is not an option here because you have a squared term, but you also have another variable. So in this case, your only option is to do quadratic formula. So it's going to get ugly, but you have a calculator. You have a equals negative 14, or I'm sorry, negative 4.9. Your b value is 9, and your c value is 1.2. So you have x equals the opposite of b plus or minus the square root of b squared minus 4 times a, which is negative 4.9, times c, which is 1.2, all over 2 times a, which is negative 4.9. Okay, sorry, that got a little sloppy. Let's do our discriminant first. So we have 9 squared minus 4 times negative 4.9, negative 4.9 times 1.2, and we get 104.52. So x equals negative 9 plus or minus the square root of 104.52. That's a positive, so I should get 2 real answers. 2 times negative 4.9 is negative 9.8. All right, so if you take the square root of 104.52, yikes, it's ugly. Okay, so let's do this. One of your answers is negative 9 plus the square root of 104.82. Nope, just kidding, 52, excuse me. Okay. Divided by negative 9.8. So one of your answers is approximately, because we're going to be rounding, negative 0.12. Okay. Your other answer comes from negative 9 minus. Remember, you have plus or minus. One goes up, one goes down. So negative 9 minus the square root of 104.52. Divide that by negative 9.8. And your other answer is approximately 1.96. Now, keep in mind, we were supposed to get 2 real answers, which we did, right? You don't have any imaginaries there. Keep in mind, though, this says x seconds, so we're going back a few units. Which one doesn't make sense? You're never going to have negative 0.12 seconds. So your answer for how long it's going to take for the ball to hit the ground is about 1.96 seconds. Okay, sorry, that's really sloppy, but you guys get it. All right, last but not least, you have a company that sells about 20x minus x squared units each month, where x is the price of 1 unit. For what prices does the company sell 100 units? Okay, well, it sells this many units. We want to know what the x value is when we sell 100 units. So we're going to take 20x minus x squared and say, okay, what is this when is equal to 100? What is x? Because x is the price per unit. So what is the price when it's equal to 100? I'm going to get everything to one side, but in this case, because my x squared is negative and that's going to be my leading term, I'm going to move everything on the left to the right. So I have 0 equals, the x squared gets added over to the other side, the 20x gets subtracted over to the other side, and the 100 was already there. Okay. Now, I'm going to look at that, and just like up above in the last question, I'm going to take that and say, okay, can I factor it first? This probably looks factorable. So 0 equals x and x. 2 numbers that multiplied to be 100 and add to be negative 20. You guys, this is what we did with completing square. That's a perfect square trinomial. Negative 10 and negative 10. X times x is x squared. Negative 10 minus 10 is negative 20. Negative 10 times negative 10 is 100. So that tells me that I have one answer of 10. So the price per 1 unit, when they sell 100 units, if it cost $10 per unit, then that means they are going to sell 100 units. Okay? So I don't even need to do the quadratic formula here in order for it to work. So that's the mentality you should be thinking. Can I factor it? If I can't factor it, can I complete the square or use quadratic formula? Solving by square roots is kind of its own deal because that means you only have one square term. So always check that too, but it's easy to cross off the list if it doesn't happen. Okay? Work through your homework. Write the quadratic formula down 10 times and you'll have it memorized. If you write it every single time, like the actual formula, if you write the actual formula, this right here, every single time you do your homework, I promise you by the end of your homework, you will definitely have it memorized. Okay, come see me Monday morning with any questions.